Welcome, this is the question 7 from that harder Edexcel C3 paper. As I said, it's the Edexcel G4 Gold 4 level from physicsandmathstutor.com, okay, of the bronze, silver and gold papers. Okay, so this is question 7. The first question is one of them R formulas. Now, just one point I want to make about this actually. Obviously, you should know the formula for R is equal to the square root of a squared plus b squared. But a and b are determined by whatever trig function you're converting it to. Okay, now we're converting it to sine, okay, so whichever trig function is sine, the coefficient of sine is a, okay. So luckily it's the first number. And generally will be, but at this stage, question 7 or 8, I would expect just to be aware that it could be the second number. The second number, if the trig function of the second, okay, so in case if this was changing it to r cos, I mean, if it was, it'd be r cos theta plus alpha, but anyway, disregarding that, if it was cos, if the trig function was cos, then even if sine was first, then we would choose the coefficient of cos to be a. So it's whichever trig function you're converting it to, the coefficient of that in the original bit of the equation will be a. Okay, so it might be a good idea to label what a is. Okay, you know, you don't have to. A is 2 and b is 1.5. Now I wrote b is 3 over 2, and I have done there, but I just prefer writing it like that. And seeing I'm doing the video, I don't see why I can't. Okay, so it's a square root. R therefore is the square root of a squared plus b squared. So it's the square root of 2 squared, which is obviously 4, plus 1.5 squared. Okay, so therefore R is equal to the square root. You can just sub that in your calculator. Weirdly enough, I don't know off the top of my head. Do apologise. You probably know it before I do, to be honest. Root 73 over 2. Okay, so that's R. A is equal to the tan inverse of b over a. So that's where it's more important. You can quite clearly say which is b, which is a. Okay, so that a is equal to the tan inverse of 1.5 over 2. Okay, and it specifically requires that a has to be to 4 decimal places. So therefore, if you were to work it out to 4 decimal places, it's 0.6435. So 0.6435. So when you've got that information, you rewrite this equation out. So 2 sine theta, take 3 over 2 or 1.5 cos theta is equal to root 73 over 2 sine of alpha, we don't know what alpha is, theta take 0.6435. Okay, now it doesn't say it wants what it wants alpha to, but you can always leave it just as an exact value specified. Okay, so that's 7a. 7b says find the maximum value of 2 sine theta, take 1.5 cos theta. Now, you're not going to be able to work it out just by looking at that equation. You need to focus on this part of the equation. Okay, now the maximum that sine of theta take 0.6435 can be is 1. Okay, basically it's a sine theta graph, but it's been stretched parallel to the y-axis by root 73 on 2. Now it has been moved to the right by 0.6435 using a standard C1 transformation of graph from the sine theta graph. Okay, but we're not really interested in how it's moved left or right. We're interested in terms of the maximum and minimums. Okay, and the maximum therefore is when you might want to specify when sine theta take 0.6435 is equal to 1. Okay, so therefore it's root 73 over 2, and that is the maximum. And the negative version of that is also the minimum, but it's not asked for that, so you just state the maximum clearly. Okay, and you're supposed to write down the value between for theta between 0 and pi, which this maximum occurs. Okay, so we just take this idea when sine theta take 0.6435 equals 1. And we need to adapt that, okay? So we need to rearrange this to get theta. Okay, so theta take 0.6435 is equal to the sine inverse of 1, and you should be aware that the sine inverse of 1 is pi over 2. Okay, now there's no point adding 0.6435, okay, to pi over 2 and say, there you are, because it's the same idea as a few questions ago where it said 3 theta and you double the range. In this, well, it still is theta, so we're not doing anything doubling, tripling the range in that sense. We're just adding 0.6435 to each reading because, well, adding that to the range because we're going to be taking that away from each reading, so you can imagine it increasing the range initially in your head. Okay, so standard thing you would do, I'll draw a, now obviously that's quite clearly not going to really affect it because 0.6435 is, the pi on 2 is a quarter of it, and that's really what we're going to be going through. And you quite think that's the angle, so it's not going to be, anyway, so it's not really going to affect our results, it's not going to give us any extra results, but, so you might have done it with a fluke by getting the right answers, but really should have sort of thought about it like that. Okay, so it's a standard standard cast diagram. So I've said this before, the bottom right quadrant is where cos is positive, top right is where all positive, top left is sine, and bottom left, bottom left is tan. Because we're only looking at sine, it's the top right and the top left quadrant, and the angles are pi and 2. Now, quite clearly, that is just a straight line, okay? Yep. So the only answer that we get, okay, is the first one, because, well, these two are the same, really. What the graph should look like is just that. Okay, just one answer, and there's no point going round again because this is clearly less than 2 pi. Okay, so only really we have this answer, but that's theta take the answer. Theta take 0.6435. Okay, so we add 0.6435 to both sides. So theta therefore is 2.2143 radians. Okay, so that's the angle at which that maximum occurs. Okay, so there's nothing more really to that part of the question. Oh, it says award 2.21. Now, if you'd have got a different value for alpha for some reason, maybe you'd have done A over B for some reason instead of B over A, or done 2 over 1.5, the same thing. It does say in the mark scheme that whatever answer you got, as long as you added it to pi on 2, okay, you would have still got the marks for theta, even if your theta wasn't 2.21 or 2.2143, okay? So it doesn't really, as I say, matter too much in that sense. Okay, but obviously you wouldn't get the marks for part A. Okay, so the next part, well, we're given this weird looking equation, and really it's quite nasty. The reason I've done it is because obviously getting, should I rub all that out? Maybe not. Oh, great. I'll just write out the equation, it doesn't really matter. Okay, now this next bit, when I've rubbed the equation back on, okay, this next bit is sort of, it's one of them questions I've put at the end because we know people are likely to be tired and start overthinking things because, well, it's towards, and if not the last question on the exam, so people are going to be thinking, oh, this is stupid, we're going to have to do something crazy. But if everyone calm down and just think about what they actually had to do in this question, it's not as difficult as it seems. Okay, so take 1.5 cos theta is equal to, what did we say that was? Root 73 over 2 sine of alpha of theta, take 0.6435. Okay, sorry, moving that off. Right, so this question says, Tom models the height of seawater, h meters, on a particular day by the equation, because, you know, he has nothing else to do with his life. Okay, so h is equal to 6 plus 2 sine 4 pi t on 25. Take 1.5 cos, the same thing, 4 pi t on 25. Okay, and t is between 0 and 12 because it's a number of hours after midday. Calculate the maximum value of the height predicted by this model and the value of t to 2 decimal places when this occurs. Now you may be thinking, oh my god, what do these things mean? It looks ridiculous, it looks stupid. I'm never going to do that. Well, look at the equation above. 2 sine theta, take 1.5 cos theta. Guaranteed there's a 6 in the way here, but if you ignore the 6, obviously we've got to leave it there, include it in our calculations. But this 2 sine 4 pi on t over 25, take 1.5 cos pi 4 pi on t over 25. Apart from the fact that theta has now been replaced by 4 pi on t over 25, they are identical. More to the point, these two angles are exactly the same, 4 pi on t over 25 and 4 pi on t over 25. Now quite clearly they don't look like angles, but they are represented as angles, okay? So, how does that help us in this situation? Well, we've just worked out sort of another, what this is equal to, which is root 73 on 2. I've done that wrong. Damn it. I knew I thought I'd done this wrong. Great. Sorry, I do apologise. I do think I've made a subtle mistake here, but I don't know how I've done that. One sec, let me just double check this. Hello and welcome, this is, well, I've just kind of figured out what was wrong, sorry about the music, pause that. Okay, so this root 73 over 2, now the calculation I did, that was correct, but for just some bizarre reason, I got it wrong. It's actually 2.5, okay, but the rest remains the same. Alright, so we were working out what was the maximum value of h predicted by this model. Okay, that's what I think we were anyway. So, and the value of t to 2 decimal places for which this maximum occurs. Well, now we know the maximum of h is when all of this is equal to 1. Sorry. Yeah, in other words, when this is equal to 1, because we said that 2 sine theta take 1.5 cos theta, which is essentially this, what this is, but we said we replaced theta with 4 pi t over 25, okay? And we said these two therefore are equal to 2.5 sine theta take 0.6435. In other words, it's 2.5 sine of 4 pi t over 25 take 0.6435. And we said that was equal, obviously, to the maximum of 2.5, because if we were to divide both sides by 2.5, that's equal to a maximum of 1. Okay? So, obviously, therefore, the maximum height is when this is... okay, so another way, actually, probably a better way of starting to write it. Okay, so it's 6 plus 2 sine 4 pi t over 25. Take this, but we said that was essentially equal to 2 sine theta, which was equal to 2.5, okay, so it's 6 plus 2.5 times the sine of the angle, which we know is 4 pi t over 25, take 0.6435, okay, and it's when the sine of the angle equals 1, so essentially it's when 6 plus 2.5 times 1, which obviously if you put that in your calculator, just wait 1 second, double check that I'm going down the right track here, should give you 8.5 metres, okay? So it's obviously 6 plus 2.5, and this is obviously equal to 1, so therefore our maximum value of h is 8.5 metres, okay? Now, we said for the maximum value this occurs that the sine of theta take 0.6435 must equal 1. But as I said, in this case we've assumed that theta is equal to 4 pi t over 25. Okay, so we apply exactly the same principle as we would be working out the maximum of this for theta, but we're told to find it, what's the range, between, oh sorry, told the range, value, maximum value of h isn't really, sorry, let me just, where's it going with that? I do apologise. No, it's not got anything else. Alright, okay, it is as simple as this. The mark scheme's going and making me go, what the hell? But anyway, as I said, this is equal to 2.5. In other words, so this is now part, so I'm not labeling my parts as well. This is still part C, but now we've worked out with the maximum of part C. So part C is really a double question in itself. Okay, so the second part of part C is where this is equal to 2.5, or just the angle bit is equal to 1. Okay, so it's the sine of 4 pi t over 25 take 0.6435, and we say that is equal to 1. So therefore, quite clearly what you do is you do the sine inverse of both sides, therefore you get 4 pi t over 25 take 0.6435 is equal to the sine inverse of 1, or in other words, oh great, sake. Or in other words, it is equal, great, I thought I'd noted that down somewhere quite clearly. I'm not as competent as I think I am. Is pi on 2, okay? I should probably know that. Okay, so then it's just a case now of rearranging that. So you times add 0.6435. Yeah, add 0.6435 to both sides, time both sides by 25, and divide both sides by 4 pi. Because what you want essentially is the value of t, the max, the time when the maximum occurs. Okay, so what you would do therefore is obviously, as I said, rearrange, add 0.6435 to both sides, times both sides by 25, and divide both sides by 4 pi. In other words, therefore you should end up with the value of t being equal to 4.41. Now obviously it doesn't specify you have to give it in hours, but it says t is the number of hours after midday. So to be more specific, it doesn't mention it in the mark scheme, but you might want to put hours, okay? There's kind of a unit thing. Alright, so that's the end really of the first little part of the question. Okay, so that's the end of 7C. 7D says calculate to the nearest minute where the times of the height of seawater is predicted by this model to be 7 metres. So times, well that quite clearly implicates more than 1. Now obviously this is the other bit that we worked out is going to be kind of irrelevant. Alright, so that will see, sorry, if you want to zip back and copy the rest of that down. This next part, okay, says when it's equal to 7 metres. Now remember, this whole equation tells you the height of the seawater at any given period. So logically, you just make that equal to 7, okay? And because 7 equals 6 plus 2.5 sine 4 pi t over 25, take 0.6435, okay? It's just a case of rearranging, so obviously subtracting 6 from both sides, okay, and then divide both sides by 2.5. Okay, hopefully your brain's able to take that weird, extravagant calculation at once. Okay, so it's 1 over 0.25, sorry, 2.5, okay, is equal to the sine of all of that, so 4 pi t over 25, take the 0.6 business. Okay, can't quite fit it on there. I didn't expect my rate to be so ginormous. Okay, and then it's just now a case of inverse sine both sides. So this 4 pi t over 25 is equal to sine inverse, sorry, that, what am I going on about now? 4 pi t on 25 take 0.6435, is it 35? Is equal to the sine inverse of 1 over 2.5. We're just going to just rearrange that quickly. So I'm fairly sure that's rearranged quickly, but just making sure. So I do apologise. It's not the slickest, but what I'm going to do. Okay, so T is therefore equal to 2.1 and remember, sorry, it's 2.1 hours, and you should remember, because we're in radians, obviously that's going to be 2.1 C, okay, and what you need to do is obviously take away from sorry, I do apologise. I probably should have had a better attempt at this, but never mind, hey. Great. You take away. Alright, excuse me. So sorry about that, made a basic mistake. Okay, so yes, correct, that is one of the times that the seawater is at 7 metres. Now, more specifically, what's the time, okay, so that's the time after midday, okay, so you obviously add that on with 2 o'clock. Now, for the T value of this, okay, sorry, so for the sine inverse of 1 over 2.5, we got 0.411. And what you do with sine, as I said, is I could prove it right. The sine, the cast diagram, okay. For every answer you get, you do pi, take the answer, and then 2 pi plus each answer, okay. And then you repeat the steps. But for this, okay, we've got sine inverse of something here, so there's obviously a couple of values for what the sine inverse of 1 over 2.5 is equal to. It's equal to 0.411, which obviously when you sub in that to this and rearrange to get T, you get 2.1 hours. But when you do pi take 0.411, you get 2.73, which when you sub into this equation, rearrange to get T, you'll get 6.7. So let me double check that is correct. Yeah, you'll get 6.7 hours, okay, after midday. Okay, and obviously you would work out, well, how long is that? What time does that give me after midday? You'll get 14 hours and 6 minutes and, 2:06 and 6:43. Or in 24-hour terms, okay, 43? Yep, 43. Okay, it's 18:43 and 14:06, but there are your two answers. Sorry, it's not been the slickest of videos, but as you can tell, that was quite a difficult question. Okay, so thanks for watching, and hopefully I'll have edited out the complete and utter shambles that just occurred there. But anyway, thanks for watching, and hopefully we'll see you in the next video.